Hello everyone, so now we're going to look at a question about ideal gas law again. So in front of you on your screen, we have a question that is requiring you to use your higher order thinking skills. Okay, so there's a situation over here that you need to imagine in order for you to get the whole picture. If you cannot picture what is going on in the question, it's quite difficult for you to get the information that you're going to be needing in order for you to get what the question wants. So the first thing that you need to do is to find out, as usual, try to figure out what the question wants you to find. Okay? So that is a very important key skill when you want to solve a given problem. Over here you have this. It wants you to determine the relative molecular mass of gas Y, okay? Question wants you to find out what is the relative molecular mass. If you still remember in chapter 1, you can go back to my notes and you can go back to the videos that we have done for chapter 1 before. Relative molecular mass, we can get the value of relative molecular mass of a species if you know what is the molar mass, okay? You can get it from the molar mass. So if we can work out, we can calculate the molar mass of gas Y over here, we can know what is the relative molecular mass of gas Y. The reason why we can do that is because of this. You need to remember that relative molecular mass will always going to have the same value as its molar mass, okay, given it is from the same species. So if we can find what is the molar mass of gas Y, we should be able to find out what is the molecular or relative molecular mass of gas Y as well. So the only thing that you need to modify from the molar mass is you need to get rid of the units, okay? Because molar mass has a unit of gram per mole, and relative molecular mass, it does not have a unit. So that is the only difference over here. That is the first example or the first hints that the question requires you to think critically, and you need to be able to relate what you have learned in the other chapter, in chapter 1 for example, into this kind of problem. So you're not only going to use PV equals to nRT, or maybe you're going to use Dalton's law or Charles's, Boyle's, and Avogadro's law in this. You're not only going to use those formulas that you have learned, but also you have to think about the things that you have learned from another chapter. Maybe we're going to use the Marmot-Vonneau tree as well. That is a very useful information. Okay, so you have to think about those possibilities. So right here, this is the starting point where you can see this question requires higher order thinking skills. It's not really straightforward. You need to think a little bit. You need to work out, churn out your brain a little bit to get the clues, okay? Therefore, the first thing you need to be thinking about for this question, how do we get the molar mass? Okay, we have talked about this before. To get molar mass, we can possibly use the formula of density of ideal gas, okay? Pressure times molar mass over RT. So this is another equation that we can use. Remember, in the other video, I have shown to you how to convert PV equals to nRT into density of ideal gas equals to pressure times molar mass over RT. You can go back to that video. You can watch that before you're gonna get back to here if you don't understand what's going on now. Okay. Now moving on to the whole question. So now we have identified that the question wants you to find the relative molecular mass. And in order for us to do that, we need to find the molar mass of gas Y. So we want to find what is the molar mass. If we can find the molar mass, we can find out what is the relative molecular mass. So we're going to start from the top. We try to visualize the whole thing because this question is telling you a story about an experiment that is being done in the lab. So when you read the question from the beginning till the very end, and then you're going to try to imagine what's going on, you will get the sense that this whole thing that is going on in here is about an experiment that is being done in the lab. Okay, so let's start from the very top. So when you look at the top over here, it says when an evacuated glass vessel with this mass over here, and then you're going to fill that with unknown gas Y, you're going to get a pressure of this. Okay, so I'm going to stop right there for now. So let's go back to the very beginning. When the evacuated glass vessel, now you are looking at a word that is maybe quite alien to you. Evacuated, what does it mean by evacuated over here? You've heard about evacuation before. Maybe you are imagining that people are being chased out from a building or something like that, evacuation. But in this case, evacuated over here simply means you have empty. So we have an empty vessel. So if we have an empty vessel, so that is my empty vessel, and it has a mass of this. Okay, so this is the evacuated vessel with the mass of 134.74 grams. So that is the starting point of the whole story. And then it continues, was filled with unknown gas Y. So you're going to fill inside your empty vessel over here with gas Y. So when you fill in that with gas, so what happens to your evacuated vessel now? It will be filled with, so let's say I'm just going to put a lid over here. So after you have filled that in with gas Y, of course, you're going to have gas Y particles inside the vessel. So in here now is your gas Y. So in the beginning, you have empty vessel with the mass of 134.74 grams. And then after you fill that in with unknown gas, you have the empty vessel with gas Y. And then it says that the pressure is 99.3 kilonewton per meter square. Okay. So now over here, what you have is inside here, you have the pressure of 99.3 kilonewton per meter square. Okay, so the pressure inside here is this, the pressure being exerted by the particles of gas Y. And then it says, so I'm just going to rub that off. The whole situation, the whole experiment, the whole trial is happening at the temperature of 31 degrees Celsius. You have the temperature. And then you have the mass. After you have filled in gas Y, the mass has increased, as you can see there. So the mass of the vessel plus gas Y is equal to 137.28 grams. So you have all of this information now. So what we're going to be doing now, we try to stop for a while and try to think, are we able to solve this problem now with all of this information given? When I have this and I have that, we can work out mass of gas Y. How do you do that? You're going to take this value, 137.28 grams, minus with the mass of the empty vessel, 134.74 grams. And you have the mass of 2.54 grams. So that is the mass of your gas Y. Now you have the mass, and then you have the temperature, and then you have the pressure. You have the pressure of gas Y over here. You have the temperature of this whole situation of the gas Y, and then you have the mass right there. Is it enough? Is it enough for us to solve the problem, to find out what is the molar mass, and then eventually to get the relative molecular mass? Okay, so remember, I'm just gonna reverse to this. I'm gonna draw your attention again to this. Remember this formula over here. So in the density formula, you can get this. This is the molar mass that we want to find out. We have the pressure, yes. We have the temperature just now, yes. And then R is just the gas constant, and that is available for you, and you should know that 0.08206 or 0.0821, whichever you would like to use, it's the same. So when you look at this equation again, is it enough? So we go back here. When we look at there, yes, we have the pressure. Okay. So if I'm gonna write the formula over here, so we have density of ideal gas equals to pressure molar mass over RT. We want to find this. We have our T, temperature. We have our pressure. R is just a constant. And now we have this density of the ideal gas. So how do we find this? Now the question is, when you have that formula, ideal gas, in this case we have gas Y. We have the pressure for gas Y just now. And then we want to find this molar mass of gas Y over R and the temperature. Okay. So we have the pressure. We want to find the molar mass. We know what is the value of R. And then we have the temperature T. And now what about this density? What about this density? So what is the formula for density? So if we gonna try to look at density ideal gas Y, we know that density is mass over volume. Okay, is mass over volume. So mass of gas Y, and we need to find what is the volume of gas Y. The information about mass of gas Y, we have it already in here, right over there. So that is mass of gas Y. But what about this piece of information? How are we going to get the volume of gas Y? So that is the question now. So I'm going to try to put all the value inside so that you would be able to visualize this better. Okay, we have the pressure just now. We're going to convert that. And then we have temperature. We're also going to convert that later on. Then we can put that in. Okay, so if we're going to plug in all the other values, we know that the density just now is mass of gas Y over volume of gas Y equals to pressure of gas Y molar mass of gas Y over R and C. Okay, so we're going to do a little conversion here. So when we do that here, the mass of gas Y, we have that about 2.54 gram. Okay, 2.54 gram. And volume of gas Y, this is the one that we want to find out. Pressure of gas Y, and then temperature. Okay, so when you look at the information again, when you look at the units of your pressure, that one is not at ATM, and then your temperature is not at Kelvin, so you need to do some conversion. So how do you do that conversion? So I'm gonna drag this. Okay. So now to convert from Newton per meter square to ATM. From the relationship over here, you can see that 1 atmospheric pressure is equals to this 101325 Newton per meter square. Okay, so you can write here 101325 Newton per meter square is equivalent to 1 ATM. The question gives 99.3 kilonewton. Okay, so the question gives 99.3 kilonewton per meter square. So just gonna write here 99.3, and that kilo, I'm gonna change that into times 10 to the power of 3. Okay, kilo is also, remember, kilo is times 10 to the power of 3. You just put it over there. You don't have to change anything over here. So that is the easiest way to convert that. Then you get Newton per meter square. You cannot use this value right away into there because kilo has its own value. Okay, so you have to convert that into Newton per meter square before you want to do this proportionality. So that one is X8CM. We want to find this. So times, you have 99.3 times 10 to the power of 3 times 1 over, then you divide with that one, 101325 equals to, you're going to get 0.98 ATM. Okay, so from the conversion, we know that this one should be 0.98 ATM. What about the temperature? So the temperature should be quite easy. So we want to convert degrees Celsius into Kelvin. Question gives 31 degrees Celsius plus 273.15. Then you get the temperature about 304.15 Kelvin. Okay, so the temperature is 304.15 Kelvin. And of course, our value is 0.0821 per liter atmospheric pressure per mole per Kelvin. So when you substitute all the value here, you get the mass is about 2.54 grams over pressure is about 0.98 atm. So we want to find the molar mass of gas Y over 0.0821 times with the temperature 304.15. Now, at this point, you can see that we have two unknown. We have this, the volume of gas. We haven't found it yet. And if we can get the volume of gas, we can find what is the molar mass of gas Y. So how do you get the volume of gas? When you read the question, if we go back to the question, when you read the question further down, it does not give you anything explicitly about the volume of gas. It doesn't say here, this is the volume of the gas. No, you have to work that out. That's why I said this type of question requires you to think critically and try to relate with your common sense. If you are able to do that, you should be able to solve this question. Okay? Now, before we're going to try to find out what is the volume of gas, I just want to bring back your attention to this. You have to remember that the volume of your vessel will equals to the volume of your ideal gas. This is the assumption that we need to do every single time you want to solve this problem. So if we can find the volume of your vessel, Okay, if you remember the drawing just now, if we can find this vessel, what is the volume of that vessel, we should be able to know what is the volume of the ideal gas, because the volume of the ideal gas will follow the volume of your vessel. Why is that so? Because according to the kinetic molecular theory of gas, we have to assume that the volume of your ideal gas is negligible because it is far too small. If you compare with the space, the big space you have in between the gas particles. Okay? If you still remember, this is what we have done in the assumptions. The first assumption, we have assumed that the volume is negligible. The volume of what? The volume of the ideal gas, the real volume of the ideal gas. What is the supposedly this ideal gas volume that we need to consider? But because the gas behave ideally, we can ignore its volume. Why? Because when you compare to the huge space which the gas molecules have to travel, and then the gas is so small, therefore it's safe to assume that the volume of ideal gas is equals to or the same as the volume of your vessel or container. Okay, so that is the first assumption that we have learned before we start this whole thing. Remember, VIMA. The first assumption of ideal gas, we have to assume that the volume of the ideal gas is negligible. Therefore, if we want to calculate PV equals to nRT, the V, okay, when you want to do PV equals to nRT, the volume over here will essentially be the volume of your vessel, because we have ignored the volume of your ideal gas, and thus it will take the volume of the vessel. Okay? So if we go back here, if we think about it, how do we get the volume of your vessel then? How do we find the volume of the vessel? Does the question gives you other information? Yes. If you look at the questions here, when you go further down, it says when the glass vessel filled completely with water, the mass was this. Okay? Now, it's good for you to draw that again. So imagine this is the glass vessel we have just now. When it is empty, the mass is about 134.74 grams. And what happened now, after you have filled in that with gas Y, so you take out the gas Y, now you're going to fill in with liquid water. Then you get this vessel now to be filled with water completely. So now this is full with water liquid. And what is the mass of the whole thing? So now the mass is going to be 1097.90 grams. Okay, so at this point, it's still not obvious. How is this information going to help you to find the volume of the vessel? Because we want to find this, because we have worked out that if we can find the volume of your vessel, we will be able to know the volume of gas Y. All right. So how is this going to be helpful? We have mass of this whole thing over here. And then we have mass of the empty vessel. So when you think about it, this water liquid, it does not only have mass, okay, but it also have, if you think critically, this water liquid has a volume. Okay, so based on the liquid property or characteristic, the volume of the liquid will be the same as the volume of the vessel that it has filled up to the fullest. So when you fill this up until here, we do know that the volume of the water liquid should be the volume of the vessel as well. This is common sense. We have done this every single day in our lives. So if you have a 2 liter or 5 liter of container, so if you fill that in up until 5 or 2 liter, you do know that the liquid that you have filled that inside that container will have that exact same volume. So this is what I've told you just now, your common sense. Okay, the whole thing just now is quite chemistry, quite informative, quite factual. At this point, you have to think slightly outside the box. You need to relate with your everyday life situation. If you're able to do that, you would be able to identify if you can find the volume of your water liquid that you have filled in here, you should be able to find the volume of your vessel. But if you look at the information given, this is the mass of the whole thing. So what can we extract from there? Now we can find out what is the mass of water liquid. How do you do that? You're going to take 1097.90 gram minus with 134.74 grams, and you will get the volume of the mass of your water liquid is equivalent to 933.16 grams of H2O liquid. So that is the mass. Can we use that mass for this calculation? Yes. Now there's another step. How do we change this? Can we change this mass into volume? Yes, by dividing that number with the density of water at 25 degrees Celsius. Okay? So what happened now? Now we want to find the volume of your vessel, and we know that it will have the same volume of the liquid that it has been filled with completely just now with the water liquid. We know that I'm just going to put that there. We know that the mass of that water liquid is about 933.16 gram. And to convert this into volume, we need to use the density of H2O liquid, and that is 1.0 gram per mil. This is a constant value. Okay, it's worth for you to try to remember this, 1.0 gram per mil, the density of water. So when you get that density of water, what can you do to get volume of H2O liquid? What you need to do, you take the mass, 933.16 gram. You're going to divide that with 1.0 gram per milliliter, and you will get 933.16 mil. So that is the volume of your liquid water, and that should be the volume of your vessel, and that should be the volume of gas Y. So this is the volume of gas Y. Okay? So what we need to do now, we're going to try to put that value in here. Okay? So now we know that what is the volume of gas Y, because we have found out what is the volume of the vessel. So what we have done just now, so we have found out that the volume of the vessel is equals to 933.16 grams, and this is also going to be the, not gram, 16 milliliter, but this one is also going to be the volume of your gas Y. All right, so we have found this, but then again, you need to remember that is milliliter, and remember this, that one is in liter. Now you're going to put in this value inside this formula that has R in it, so you have to change that into liter. So to change that into liter, what you need to do, you're just going to divide that by 1000, and you get 0.93316 liter. We have that value, we have this value, we have that value, and that value, and that value. And now we can solve the problems. How do we solve that one? Okay. So I'm going to rewrite that very quickly. What we have just now is 2.54 grams over 0.93316 liter equals to 0.98. So we want to find this molar mass of gas Y over 0.0821 times 304.15 Kelvin. So when you solve all of this, you should be able to get the molar mass of Y is equals to it's going to be about 69.356 gram per mole. So that is the molar mass. But what is the relative molecular mass? The answer is just 69.356. You're just going to take out the constant. I mean the units over here, not the constant. You're just going to take that out.